Saxon's Calculus Lesson 96 is rules for even and odd functions. So the first thing they remind us of is when we add two odd numbers that we are basically getting a bigger odd number. Same thing with, not odd numbers, sorry, negative numbers. And the same thing with positive numbers. And when we multiply, of course, both multiplying two positives and two negatives both give a positive answer, and multiplying a positive and a negative would typically give a negative answer. And same rule for division. Jump to example 1. If f is an odd function and g is an even function, show that the multiplication is an odd function. So they basically want us to prove those rules. So as a reminder, so this one said f of x is odd. When you do that and you plug in, you get a negative in front of that f of x. And then g of x was even, so it's going to not have any negative with it at all. And when you put those together with the negative out front, then it is basically the negative of those two multiplied. So the actual look there would be negative fg of x. And really it's just kind of that verbal. Example 2, show that the sum of two even functions, f and g, are even. So we're basically saying we have f plus g and they are both even. Yep, and so they would come from f of x plus g of x, there we go. And that's basically what that means. And since they're both even, then I have even answers. There's no negative to come into play at all. Example 3, if f is odd, so again, this is what we're dealing with, and g is even, show that adding them is neither even nor odd. So the idea here is they're saying we've got f plus g of a negative x, and if we're separating that, then that's f of negative x plus g of negative x. And our problem is if one of them is positive and one of them is negative, the sign is changing, and so you end up with a negative outside of one of them but not the other one because it's even, and that's just like we don't know how to deal with that. So it's not even or odd, it doesn't fit. Example 4, show that the quotient f over g of x is an odd function if f is odd and g is even. So now we have f was odd, okay, and g was even, and so when you divide overall, that basically makes negative of the overall statement. Example 5, if f is even and if the integration of 4 to 2 f of x dx is 7, evaluate from negative 4 to negative 2 f of x dx. Okay, so this one is basically a thought process. So if you're picturing on the number line, the distance from 2 to 4, that's obviously 2 units away this way and 4 units to there. And then this one is going negative 2 to negative 4. Well, that's the same distance to the 2 and the same distance to the 4 running in the negative direction. And so since this is even, it said, that tells me that it is symmetrical about the y-axis. So if I fold on the y-axis, the two, whatever the curve that would be graphed should match. Oh, that was a lousy, that does not look the same, but I'm supposed to be drawing it the same. So whatever this distance is should be exactly the same distance here. So just with a little thought process on the fact that it's even, therefore the y-axis is the fold, this is 7. Now they say it's a trick problem, but basically they just want to know, can you think your way through it? Now, example 6. If the integration from negative 2 to 2 of e to the x squared dx equals k, what is the value of the integration from 0 to 2 of e to the x squared dx? All right, so if I'm picturing the number line again, from -2 to 2, and then 0 to 2, that's half of the amount. So since this was k, then the answer is going to be k over 2. All right, example 7. Not much space. Depending on it, I might be able to cram it in. If f of x is odd, and from 0 to 2, let me just write it over here. Okay, so from 0 to 2, it says f of x dx equals 16. What is the value of integrating from 2 to -2 the f of x dx? Okay, so, and it's odd. All right, again, I'm going 0 to 2, and then 2 to negative. So I'm doubling it. However, it's odd. So I need to remember that odd changes it. So like if this is swooping this way, this is swooping this way. Because it's not folding on the y-axis, it's mirroring around 0. And that being the case, their area underneath between those two is definitely the same area, but this one is in positive and this one is in negative. So if I combine the same number, assuming 16, on the positive side, then I've got -16 on that side, and they're going to cancel each other out, so we are going to get 0.